A scientist's measurements must be both accurate and precise. But what's the difference between accuracy and precision? Here's an example. Darts scattered evenly around the bullseye is an example of accurate but not precise. Darts concentrated in one spot, not the bullseye, is precise but not accurate. Darts concentrated in the bullseye is both precise and accurate. In science, inaccurate measurement can lead to systematic errors that can bias data. In turn, biased data can lead to erroneous conclusions. Let's learn more about accurate measurement. Accurate measurement supports the welfare of our society and affects every part of our modern world. Measurement plays a fundamental part in our lives. We measure time to be sure we make a flight. We measure speed to avoid going over the limit. We measure wind speed to predict weather. Measurement is also widely used in manufacturing and medicine. To make accurate measurements, the scientist uses the appropriate instrument, designed to fit the purpose. The type of instrument used to make physical measurements depends on the scale of the object. For example, to measure a piece of wood, a tape measure is suitable. However, a tape measure could not precisely measure a small object. Engineers routinely use a micrometer to measure small objects. Likewise, to measure the distance a vehicle travels, a tape measure would be unsuitable. Therefore, the distance traveled by a vehicle is measured with an odometer. In the case of an aircraft, a pilot will need to measure both the distance and direction. Radar technology provides a way for the pilot to measure both distance and direction. In experimental observations, systematic errors may arise because of problems with measuring instruments. Errors occur because there is something wrong with the instrument or because the experimenter uses the instrument incorrectly. For example, misreading of a scale will result in erroneous measurements. As well as the scale of an object, the substance being measured determines the appropriate instrument. Gas is usually measured by volume using pressure gauges. Scientists measure the volume of a liquid with graduated cylinders and beakers. The volume of relatively simple solids can be calculated from linear measurements. A measurement will be inaccurate if the operator fails to read the instrument correctly. For example, when measuring a liquid, the reading should be made using the meniscus, which is the curved surface of a liquid. In most liquids, measurement should be made from the bottom, the lowest point of the curved surface. In many measurements, the observer must ensure a correct line of sight to avoid parallax error. In most cases, the user's line of sight should be perpendicular to the object being measured. A different angle will give inaccurate readings. Inaccuracy can lead to unintended consequences, not just in scientific experiments, but in everyday life. For example, an inaccurately measured dose of medicine may harm a patient. A truck weigh station must weigh trucks correctly. The result of an incorrect measurement could be an unsafe load, leading to an accident. In many industries, the measurement of force is needed to ensure safety when an object is lifted or during a push or pull. A force gauge is an instrument that gives a readout directly in newtons during a push or pull test. A force gauge would be used to measure the centrifugal force on the chairs of a carousel swing. The measurement would ensure the forces on the chair cables were within safety margins. Imagine if a climbing rope's force rating was measured inaccurately. It could potentially break while being used by a rock climber. Accurate measurements are necessary in so many aspects of our increasingly technological world. Ensuring accuracy ensures that experiments get good results, that people can remain healthy, that technology is safe, and that we better understand how we're impacting our planet.